The high bay's days are numbered as SpaceX starts to dismantle it and prepares for the upcoming Giga Bay. The company is also continuing major work at Starbase's Pad B, with more Chopstick testing and hundreds of deliveries of concrete being poured into its flame trench. There's been a recent shuffle of boosters at Starbase, leaving us wondering about the future of reusability, and of course, Elon has once again given a reality-defying timeline for Starship. But is there any realism to it? Stick around, we've got a lot to cover in your Starbase update. If you recall from last week's episode, you might remember we talked about the upcoming Giga Bay at Starbase and how SpaceX would need to take down the high bay and even parts of the current Star Factory to make way for it. Well, right after that episode was published, SpaceX did indeed start dismantling the high bay. This building had supported the Starship program since the early days, with its single welding turntable and gantry crane assembling the early ships and boosters. I still remember the day SN9 ended up leaning against one of the corners of the high bay. It's bonkers to think that was the first ship to have its full stack done inside of this building. I also remember the days when SpaceX had to cut a hole in the roof to get the crane to reach in just to build a booster because, well, they hadn't installed the gantry crane yet. Now, unlike what we saw with the mid bay, the high bay isn't going to be coming down with explosives, or at least not yet. This is partly because the high bay had an extra level on top of it, the high bay bar, which means there's a lot of concrete and other heavy duty materials up there that need to be carefully removed first. Also, the surrounding area is still an active manufacturing site. Remember how they had to take down the tents before demolishing the mid bay? And the high bay is significantly larger than the mid bay, even though it looks small in comparison to the mega bays and the soon to be Giga Bay. Right now, the work is focused on that roof level I just mentioned, cutting up all that material and bringing it down piece by piece. As we saw last week, SpaceX has set up scaffolding at the entrance of the bay and put up barriers at the entrance to the production site to stop people from going in. SpaceX has also begun dismantling some of the adjacent support structures closer to the ground next to the high bay, and given the size of the future Giga Bay, I'd say there's a good chance the Stargate building will be removed as well. To aid in the dismantling of the high bay, SpaceX has brought a crane to the production site to help lower large sections of the building for scrapping. The crane in question is a Liebherr LTM 11200, and for those who remember all the way back to 2019, it's the same type of crane SpaceX used to stack Mark 1 ahead of the 2019 Starship presentation. You know, with the high bay on its way out and this type of crane making a return, it really does bring back some memories. Hopefully, with patience and relentless work, the high bay will finally come down and we'll see teams getting started on the foundations for the Giga Bay, and that will be a sight to behold. In the meantime, thank you for your service, high bay. Okay, it's time to go through everything launch site related, starting off at the production site, because of course the launch mount for Pad B is being constructed at the Sanchez lot. You might remember that last week we pointed out what looked like a water deluge pipe being installed on the side of the mount. Well, it turns out this is actually a water deluge manifold line, and since then teams have been busy connecting it to all the smaller pipes attached to the top deck plate of the mount. As it stands, only a few of these smaller pipes have been hooked up to the manifold, but bit by bit it's all coming together, and before long SpaceX will have a fully completed deluge piping system. Once the launch mount is complete, it'll roll down Highway 4 and make its way to the launch site. Once there, it'll need to be hooked up to something that can supply all the necessary systems to run the mount, things like high pressure fluids for hydraulics, the deluge system, maybe even the booster umbilicals. Exactly how all of that will be set up is still a bit of a mystery, but we do know that SpaceX is building a gantry to connect to the OLM and provide these utilities. Over the past few weeks, we've seen basically just the framework, but last week floor panels started appearing on different levels of the structure. SpaceX has also put up a lot of scaffolding to access the gantry's various levels while it's under construction. It's quite interesting to see the possibility of floors inside this gantry, because that could mean it'll be used for accessing the OLM between flights, making inspections and refurbishments much easier. Keep in mind, this whole structure will eventually be enclosed and reinforced to withstand the extreme forces of launches and landings, so having a way to get inside for maintenance might be a really smart move. But if there's one thing at that launch pad that really needs to survive a launch, it's the new and massive flame trench being built at Pad B. This pad is being designed with the future versions of Super Heavy in mind, and SpaceX has confirmed that they plan to upgrade it to handle at least 10 1,000 tons of thrust at liftoff. That's a lot of energy that needs to be contained and channeled into that trench, so it needs to be built to withstand some serious forces. On top of that, it also has to be capable of quick turnarounds to support the many launches of Starship down the line. To tackle this, SpaceX is reinforcing the trench in several ways. Aside from the dozens of pilings they've driven into the ground so far for the foundations and other structural reinforcements, the ground that will eventually support the two-sided flame bucket is being filled with concrete. This week, SpaceX had a whole parade of concrete trucks delivering and pouring concrete for exactly that. Depending on which nerd you ask within the Starship community, it seems around 300 trucks or more travel to the launch site down Highway 4 to deliver the concrete. To put that into perspective, this is about the same number of trucks we saw when SpaceX poured the concrete on the foundations for the flame deflector at Pad A. What's quite funny is to think that this is still nowhere near what they'll need to fill up the base of the trench. It's estimated that we'll need 3 or 4 more of these parades, that's about 1,000 trucks, to get the entire thing done, which is bonkers to even think about. While the bottom is reinforced with this concrete and will eventually hold the flame bucket that should protect it from the fury of the engines, what about the walls of the trench? For a while, we suspected something had to be done for the sides of the trench, and there were a few theories floating around, but thankfully, we no longer have to guess. It looks like the trench will be fitted with an armour of sorts, with steel walls on each side that will have a layer of concrete on the inside. This week, SpaceX brought parts of that wall to the launch site, and it even looks like some of them might have already gone down into the trench. We can see that the parts are made up of 2 steel plates with a gap in between. That's where the concrete will go once they're installed. So this means we'll see even more concrete being poured here eventually once these steel walls are in the trench. I guess we're going to have to start a concrete truck counter for Starbase Live whenever they start doing this again. Another piece of great progress that SpaceX has made in the last week has been with the Chopstick arms at Pad B. Prior to Flight 8, we saw them testing the carriage and drawwork system by raising the chopsticks up the tower a bit and then setting them back down. This week, however, they went all the way to the top for the very first time. This major milestone was preceded earlier in the week by the removal of scaffolding from the carriage system and a test performed to a partial height. SpaceX really seems to be working towards getting this system ready soon, and while there's still a lot of uncertainty when they might get used, mostly due to the failures on Flight 7 and 8, the sooner they're ready, the sooner they can move on to readying other systems. Now, it's worth pointing out that this lift to the top of the tower was just the arms and no load. It wouldn't be surprising if, in the next few weeks, we see SpaceX try out similar tests but with the weight bags they used on Pad A's chopsticks prior to the first ship stacking. As teams close out more and more of the systems on Mechazilla, we may also see tests where the arms open and close and even perform catch simulations. In the last few weeks, SpaceX has been delivering new big water pipes to the launch site. We presume this is most likely for the deluge system that will be installed at Pad B, which is also taking shape. It's not just big pipes being delivered, but also large manifolds, as we can see here, being driven down Highway 4 out to the launch site. Take a look at the scale of this thing. Just compare it to the nearby road signs or the cars following behind. That's one massive pipe. It's not surprising given the huge amounts of water that will need to flow to the pad, but still, pretty impressive. Oh, and if you didn't have enough concrete pouring with the flame trench in the last few days, we've also seen several trucks pouring concrete near where the deluge tank farm is being installed, as well as near the tower on the side facing the road. If one were to guess, SpaceX is likely pouring this concrete in the trenches that hold the propellant lines and other fluid lines that run out to the tower and flame trench area. If you think we're finished discussing the work at the launch site, think again, because there is much more to discuss. For those who have been watching for a while, you might know that the launch site tank farm operates in a 1-for-2 setup, one set of storage tanks for 2 launch pads. However, it makes sense to make everything else pad specific so that what's stored in those tanks can be directed to either pad as needed. As a result, SpaceX is installing a whole bunch of cryogenic pumps and subcoolers dedicated solely to Pad B. This process has been ongoing for a while, and this week, for example, SpaceX brought in another new subcooler for installation on that side of the tank farm. They've also added another cryogenic pump dedicated to Pad B, bringing the total to 4, with more expected in the coming weeks. It's believed that these pumps are primarily for liquid oxygen, and SpaceX could install as many as 9 in total. Additionally, we've seen more stands arriving, which will support these pumps at the pad once they're installed. At the same time, teams are also working on a new protection and retention wall on the road-facing side of the tank farm. You guessed it, more concrete. At least this time, the amount of concrete needed is relatively small compared to what's getting poured at the flame trench. In addition to all of this, we've also started to see valve panels arriving at the launch site. These panels, which include a variety of valves and gauges, are used for controlling and checking fluid systems. We've seen similar panels at Pad A before, both in the tank farm area and on the launch mount. Well, before the shielding was installed, that is. So it's likely that these panels will go into similar places at Pad B, like the new gantry, deluge tank farm area, and other critical systems. Finally, on the long list of deliveries this week, 2 large electrical power bunkers were brought in. These bunkers first arrived at the port of Brownsville via barge and were then transported down Highway 4 to the launch site. The first bunker was installed right in front of the tank farm near the subcoolers and pumps dedicated to Pad B. The second bunker was initially parked near Starhopper but was then moved to the launch site. These power bunkers are believed to be holding and protecting the electrical systems needed for the launch site, especially considering that rockets will soon be launching and landing next door. Safety and reliability are key, so these bunkers are an important piece of launch infrastructure. You wouldn't want to, say, have to pause an entire day's operations, causing worldwide chaos because of an electrical issue. In the time since those buildings arrived, we have also witnessed new tanks being delivered by boat to the port of Brownsville. It is not certain that these are intended for SpaceX, but to be frank, they are currently the only Brownsville area company bringing in a great deal of materials via barge, so there is a strong likelihood these tanks are for them. As to where these new tanks would be situated should they indeed be for SpaceX, it is not entirely clear. However, they could potentially be destined for the launch site, the Massey's outpost, or perhaps even both, depending on where the extra capacity is needed. SpaceX has also been diligently working at the launch site, continuing with refurbishment and inspections at Pad A in preparation for the next Starship flight. Over the past week, it seemed that the teams were particularly focused on inspecting one of the hydraulic actuators on one of the Chopstick arms, likely one of the many components on the list of post-flight checks. In addition to this, we have observed SpaceX installing a plate on the booster quick disconnect port on Pad A's launch mount. This is a plate that had appeared in previous post-launch campaigns, and it appears to replicate the quick disconnect port on the booster side of the system. It is possible that SpaceX is using this device to test the compatibility of the launch mount's quick disconnect with the vehicle's umbilical port, ensuring that there are no leaks during the process. While we're on the subject of launch site operations, it seems only fitting to mention some of the latest updates concerning the ongoing work at the Starship launch pad at LC-39A in Florida. SpaceX is actively working towards getting this launch pad operational for a launch later this year, and as part of this effort, we've observed them dismantling much of the old tank farm systems, an endeavour we highlighted in the recent Space Coast flyover. Since then, the teams have continued clearing the area to the north of the Starship launch pad, as seen in the recent footage during the Crew 10 launch coverage. Moreover, just a couple of months ago, we began to witness the drilling of piles that will form part of the foundations for the flame trench at the site. In order to excavate the flame trench, SpaceX needs to drive sheet piles into the ground. These essentially act as retention walls, preventing the digging area from collapsing during excavation. This was a process we observed when SpaceX worked on the foundations for Pad A's flame deflector, and we later saw a similar approach when they began the Pad B flame trench. And as of this week, we saw exactly the same work being carried out at LC-39A for that pad's own flame trench. This marks the beginning of work at the site, meaning it's approximately 8 months behind the progress we observed at Pad B's flame trench. However, it's worth noting that at LC-39A, they have already constructed a complete tower and installed a set of chopsticks and a carriage system. Speaking of those chopsticks, we've also noticed cranes and lifts working adjacent to them in recent days, including one that seemed to be lifting materials to one of the arms. Although it is difficult to make out due to the distance and heat haze, it's Florida after all, it's possible that SpaceX has commenced work on reinforcing the arms, much like the reinforcement work at Pad A and Pad B. However, it should be noted that, in the case of Pad B, the chopsticks were reinforced before being installed on the tower. At Starbase, there's of course a great deal more activity than merely construction, so let us now turn our attention to the vehicles at the production site, where some notable shuffling has been taking place. In our previous 2 episodes, a particular question repeatedly arose as we navigated through the updates. Where will SpaceX fit all of its boosters if they continue to catch them while also building new ones? This week, we may have discovered the answer to that question. It all started when a booster cap was moved into Giga Bay 1. This cap, typically installed on the forward end of the booster to protect it from the elements when stored outside the bays, signalled that a vehicle had to be moved out of the space. Inside Mega Bay 1, we already knew that SpaceX had boosters 14, 15 and 17, thus, with the arrival of the booster cap, one of those boosters was bound to be moved. And indeed, that's exactly what transpired. In this instance, it was booster 15 that rolled out of Mega Bay 1 and was relocated to the rocket garden. This is rather interesting, as booster 15 is flight proven and has now joined booster 12 in the garden. However, unlike booster 12, booster 15 is carrying a booster cap on top. This suggests that SpaceX is taking measures to keep the booster in relatively good condition, which implies that it may indeed be reused at some point in the future. However, it's clear that this reuse would not be in the immediate future, and with space in the Mega Bay being at a premium, teams likely need the room for other vehicles. But you might be wondering, why would SpaceX need to make room in the Mega Bay? The answer lies in the need to accommodate booster 16. This particular booster had previously undergone cryogenic proof testing at Massey's prior to Flight 8 and had been sitting there for quite some time. This week, SpaceX moved it back into the Mega Bay following the departure of booster 15. Now that booster 16 is safely inside the bay, the teams will continue with further outfitting and begin installing its Raptor engines in preparation for its upcoming flight. While we still have yet to receive confirmation on whether this booster will be used for Flight 9 or if SpaceX will opt to reuse booster 14, it's clear that it's wise to start work on it as soon as possible, even if its first flight isn't until Flight 10. One key point to add is that on top of all of this, for some time, booster 17 has been stationed in one of the front corners of the Mega Bay after being fully stacked. However, when booster 16 was rolled back into the Mega Bay and the building door was opened, it became apparent that a booster without grid fins had now taken up the central workstation. This, of course, was booster 17, which explains why SpaceX had to make room for booster 16 as all three workstations were occupied. Speaking of booster 17, this week we also observed a long cylindrical metal tank being lifted inside the Mega Bay. This could well be the installation of the vehicle's carbon dioxide fire suppression system tanks, which are essential for ensuring safety during operations. This week we also had the opportunity to catch a glimpse into Mega Bay 2 on a couple of occasions. On one of those, we observed what appeared to be a pressurization pipe being lifted inside the building, likely as part of the outfitting of Ship 36's tank pressurization system. Later on, Ship 36 was seen on the central workstation, having been moved from the welding turntable to this location within Mega Bay 2. What's particularly interesting is that this ship is missing a significant number of tiles. At present, it only has the white protective felt and the pyron ablative material, which serves as a backup heat shield. This mirrors what we also noticed last week with Ship 37's nose cone, which had a substantial number of tiles yet to be installed. For some reason, it seems as though SpaceX might not be prioritizing the tile installation at this stage, instead focusing on other systems. And probably not a bad idea, given the recent two failures, and on top of that, it also seems that the boss up top is keen to accelerate the pace of Starship launches. If last week Elon was discussing Starship's timeline to Mars, this week we received another post on X addressing the upcoming version 3 of Starship and the rather ambitious Cadence goals for Starship in the coming year. For version 3, Elon Musk states that SpaceX is refining the design for the rocket, but what's particularly intriguing is that he mentions this version will deliver around 100 tons to the Starlink orbit with full reusability. This orbit is at a higher altitude and inclination than the standard reference orbit used for rocket performance, but it's still quite noteworthy when compared to the performance goal from a year ago of 200 tons to low Earth orbit for version 3. It wouldn't be surprising if, following SpaceX's tradition, what we knew as version 3 last year actually ends up being another version further down the line, and this may well be a new version 3 closer to an enhanced version 2 than a radical stretch of the rocket. Elon also mentions that SpaceX is aiming for a launch rate of Starship once per week in 12 months, which would mark a significant surge in cadence. When put into perspective, this would represent a 7-fold increase compared to the current pace, since at present the cadence stands at roughly one Starship launch every 7 weeks. This would mean launching Starship 7 times faster than that. But is this realistic in any way? Let's examine this from multiple perspectives. The first comparison is to Falcon launch cadence. Many of you are likely familiar with the fast cadence of launches from the Falcon program, and it's tempting to think that Starship could follow a similar path. However, it's important to point out that Falcon didn't achieve this high cadence overnight. It took years to reach this level, with each year seeing a modest increase in cadence. On average, Falcon 9's cadence increased by about 60 to 70% per year once SpaceX aimed to ramp up its pace. When you add up those increases over a 5-year period, it results in significant progress, and this explains the current position of Falcon 9. However, SpaceX has never been able to ramp up its cadence by 7 times within just a single year, which is the goal they are now targeting with Starship. So, can Starship break this record and come close to such a target? This is not the first time we've heard these lofty high cadence goals for Starship from Elon, but as we know, none of them have been realised thus far. For instance, last year we were told that SpaceX was targeting 25 Starship launches in 2025, which would have required a cadence increase of over 6 times of the pace we saw in 2024. As of now, SpaceX has increased its cadence by about 60% compared to last year, quite similar to the situation with Falcon 9. Although it must be said the 2 Starship launches so far have not been successful in the traditional sense. That being said, this is far from catastrophic. It merely means that progress will take a bit longer. If we were to extrapolate this cadence increase over time, we would still be looking at hundreds of Starship launches per year before the end of the decade, which I'm sure you'll all agree is still an impressive cadence. But let's set the numbers aside for a moment. What would need to happen for Starship to achieve this cadence within the next 12 months? Well, a ramp up in production would certainly be beneficial, as would be reducing the pad turnaround time. Most importantly, if SpaceX can bring online Pad B at Starbase and the Starship pad at 39A in Florida, that would give them more locations from which to launch Starship, thereby facilitating a higher launch cadence. Landing and reusing boosters and ships will also contribute once that process becomes more regular. What's crucial to understand, however, is that these extreme timelines are deliberately set in place to kickstart all of this work, with a drive to achieve the seemingly impossible. And as Elon himself often says, SpaceX turns the impossible into late. This is something we've already witnessed with Falcon. So while a weekly launch cadence for Starship may seem far-fetched in a year's time, perhaps in 2 or 3 years it will be entirely feasible, and when that moment arrives we'll be quite busy here covering it all as it unfolds. That's going to be it for this week's Starbase update. I've been Ryan Caton for NSF, thanks for watching, and goodbye.